In this video, we will go over transformations of graphs. A vertical shift, the graph will shift up or down. Horizontal shift, the graph will shift left or right. So this is the starting function, and then we have these two pieces. So we want to identify whether we will have a vertical shift or a horizontal shift. And if you want, you can pause the video here and attempt this problem. So this will be a vertical shift. So if you notice, we went down -2. And this will be a horizontal shift if you notice we went right 2. Let's say the parent function is y is equal to x squared minus 5. And that's represented by the blue graph. And then the graph in red, we are multiplying by 2. And so we're saying 2 parentheses x squared minus 5. This will be a vertical stretch because the y values are doubled and the points get further away from the x-axis. And as an example, so for the blue function, when x is 0, y is -5. But for the red function, when x is 0, y is -10. And so if you notice, the y values doubled, and we're getting further from the x-axis. So this point right here is further away from the x-axis than the blue function. So again, parent function is y is equal to x squared minus 5, and now the red function is y is equal to 1/2 parentheses x squared minus 5. So the y values are halved and the points get closer to the x-axis. So for the blue function, x is equal to 0, then y corresponds to -5. And for the red function, x is equal to 0, then y is equal to -2.5. So the y values are halved and the points get closer to the x-axis. And so this would be a vertical shrink. Now for a horizontal shrink. So again, same parent function, but instead the red function would be y is equal to parentheses 2x close parentheses squared minus 5. And so in this case, the x values are halved and the points get closer to the y-axis. For example, when x is equal to 2, then our y is equal to -1. So we get 2 squared minus 5, so y is -1. Now for the red function, when x is 1, we would get 2 squared, so 4 minus 5, and we would get y is equal to -1. And so if you notice for the red function, the x value gets halved, so from 2 to 1, and because of that, the points get closer to the y-axis. So this y-axis here is getting closer. So another case, so we have a horizontal stretch, so the x values are doubled, points get further away from the y-axis. So same parent function. Now for the red function, parentheses 1/2 x squared minus 5. And so as an example, for the blue function, if x is equal to 1, then y is equal to -4. So 1 squared is 1, 1 minus 5 is -4. And for the red function, if x is equal to 2, we get 1 minus 5, so -4. So the x values are doubled. X values are doubled from 1 to 2. And the points get further away from the y-axis. So this point right here is further away from the y-axis compared to this point. So this is just a recap. So if you have a vertical stretch or shrink, it changes the y values of the points. So if k is greater than 1, you would have a vertical stretch. But if k is less than 1, you would have a vertical shrink. And for a horizontal stretch or shrink, it changes the x values of points. So if k is greater than 1, we would have a horizontal shrink. And if k is less than 1, we would have a horizontal stretch. Also, one more point, when I say less than 1, it's like greater than 0, but less than 1. And that's pretty much it for this video.